So here's 27 from the 3-3 homework. Let's look at what they've asked. So they said the graph of the derivative is shown. So that is the derivative there, okay? From that graph, they want to know where is the function increasing, decreasing. At what values of x does the function have a local max or local min? On what intervals is it concave up or concave down? State the x-coordinates of the points of inflection. Assume that f of 0 equals 0. Okay. And then sketch a graph of f. Let's analyze what we know. Okay. So this means I'm going to first take this information, and I'm going to go from 0 to 9. And I'm going to change it into a number line chart. I'm going to make it a plus minus chart because the plus minus chart for the first derivative is what's going to kind of help us, okay? So we have zeros at 2 and 4 and 8, okay? So 2 is important, 4 is important, 8 is important. Those are zeros. Well, what do we know about the zeros? Well, the zeros have to be local mins or maxes because the first derivative, where the first derivative is 0, is a local min or max. So that's going to help us find the answer to part B, okay? 6 is also a weird spot. Remember, a critical number can also be where the first derivative doesn't exist. So let's put a little closed circle at 2, 4, and 8, and let's put an open circle at 6. Okay. Next, let's talk about increasing and decreasing. This part of the derivative is positive. It's above the x-axis. So let's put a little positive here between 4 and 6, and then from 8 to 9. Okay? So if we were to discuss where the first derivative, or where the original function is increasing, it would be where the first derivative is positive, above the x-axis. So for part A, it is increasing from 0 to 2, from 4 to 6, and then from 8 to 9. Okay, so that, and we could even assume maybe if this keeps going on like that, that it would be to infinity. But they didn't really kind of tell us one way or the other. Okay. Next, where is it negative? That's where it's decreasing. So it is decreasing here because see how the graph is negative and the graph is negative there. So it is decreasing from 2 to 4 and from, let's see here, from 6 to 8. Okay. Now, local mins or max. Don't use the graph anymore. Use the plus minus chart we have created. If a point goes from increasing to decreasing, then it's going to be a local max. So if we look at 2 here, it was increasing to decreasing. So this is a local max. Okay. Well, what do we know about 4? Well, it was decreasing then increasing. So that is a local min. Now 6 doesn't count. 6 isn't a point that that works. Well, it's not a point where the derivative works, but it still is a critical number. So if we look at what's happening there, This goes from positive to negative. That is a local max as well. And then 8 goes from negative to positive. It's going to be a local minimum. Okay. What's next? Concave up and down. So let me erase the junk I've drawn here. And now we're thinking about the second derivative. Now, what's the second derivative? Well, the second derivative is the derivative of the derivative. So the slopes of the tangents of the graph we see. Well, let's again talk about 2, 4, 6, 8, and 9. Okay, so I'm going to make another plus minus chart. Okay, and then let's think about where the zeros are for the derivative. Well, this is a zero slope, right? So 3 is very important. That's a 0. What other points are important? Well, 6 is undefined. So it's important. So the places we're going to look for are 3 and 6, kind of as our separation. So what do we know? Well, here, the tangent lines, because it is decreasing, is negative. So that would be negative. The second derivative would be negative. Here it's increasing. The slopes are all positive. And here again, the slopes are all positive. Well, what does that tell us? Well, it tells us the concave up and down. It tells us if we have a point of inflection. Okay, so let's look at what we know. This is a concave down spot from 0 to 3. So there's 3. And then there is a concave up spot from, let's see, 3 to 6. And then there is another concave up spot from 6 to 9, or possibly infinity, if we're going to assume this graph keeps going and going and going and going. So what's a point of inflection? Well, this is the only one that is a point of inflection right here. That's a change from negative to positive. And so we have a point of inflection when x equals 3. Okay? So now think about everything we have. We have where's the function increasing and decreasing? What it says to assume that f of 0 equals 0. So we're going to start at 0 and we're going to draw our graph up. Okay? So let me add a sheet of paper here. And then let's if it lets me. Sometimes lately it's been being weird. So let's put all the pieces together. Okay? Okay, so it starts at 0. It is increasing and has a local max at 2, and then the concave down stops at 3. So I'm just going to kind of go, okay. Now, it is concave up until we hit 6, okay. It keeps decreasing until we hit 4, and I'm just taking the things, and then it keeps increasing until 6. It has a local max at 6, but it was not differentiable. That's why we had that it must have a pointy point or something there. And so, and it's still concave up. And 9, we don't know if it keeps going or whatever. So our graph would look something like that, and that would match all the stuff we just found from that problem. Okay? Okay, so we had zeros at 2, 4, and 0. We put the information about the negatives and the positives and made a plus or minus chart, and then analyze what that means. Okay, so it's going to be increasing, decreasing, increasing, decreasing. So 0 is a max, 2 is a min, 4 is a max. Now let's do the same exact thing for our second derivative. We're going to make a plus or minus chart there. The things mentioned on this is 1 and 3. Okay, so it says that it is greater than 0 or positive between 1 and 3. And then it's less than 0 or negative on these two sides, less than 1 and greater than 3. So what does that mean? Well, that means we know some information about the concavity. This is concave down, a frown or a cup that's upside down, a bowl that's upside down. Concave up, a smile, a cup that is up, and concave down. What do we know? Well, there are 2 inflection points, right? Because of the fact that we have a change in concavity twice. We have inflection points when x equals 1 and when x equals 3. Okay. Now let's go ahead and put this on to a chart. Now there's so many different placements of the graph, but this will definitely at least get us started. Okay. So we have a local max at 0, a local min at 2, a local max at 4. Okay. What else do we have? It's concave up between 1 and 3. So from 1 to 3, our cup is up. Okay. The other sections, our cup is down, so we're going to have to go like that. Our cup is down. Okay? So our graph fits all of the criteria. Look, it is increasing, decreasing, increasing, decreasing. That fits that. Local max, local min, local max. Let's fit this. Concave up from 1 to 3. Concave down from anything to the left of 1, concave down anything from the right of 3. Okay, so from here, there. So these points we could even put on 1 and 3 are changes in concavity, are inflection points. Any questions about that one? That is it for your 3 homework. Good luck on that, and if you need me, you know where to find me. Okay, bye.